Welcome to EduCasts, home of EduCasters. If you have ever taken a Psychology 101 class, you have probably seen that black and white image where you either see two faces staring at each other or a vase in the middle. It is the classic face-vase illusion. It's a neat party trick, but for educators, that image represents something way more profound than just a visual hiccup. It represents the way our brains are hardwired to make sense of the world. We don't just see random splotches of ink. We see a picture. We see a whole. This is the heartbeat of Gestalt theory. While it started in the dusty labs of German universities in the early 20th century, its application in the modern American classroom is as relevant as ever. In fact, if you are a teacher who cares about light bulb moments rather than just drilling facts into kids' heads, you are probably already using Gestalt principles without even realizing it. Gestalt theory in education isn't about memorizing a list of perception laws. It is about understanding that learning is a holistic process. It is the idea that the whole is different from the sum of its parts. Note that I said different, not necessarily greater, though that is how the quote usually gets tossed around. The point is, you can't just break learning down into tiny, disconnected nuggets of information and expect a student to truly understand the subject. You have to look at the big picture. We are going to dive deep into what Gestalt theory actually is, how it pushed back against the rigid teaching methods of the past, and how it plays out in real time within our classrooms. We will break down the laws of perception not as abstract concepts, but as practical tools for lesson planning. We will also look at the magic of insight learning, that moment when a student suddenly connects the dots. So grab a cup of coffee and let's flesh this out. The history, a rebellion against the machine. To really get where Gestalt theory is coming from, you have to understand what it was fighting against. Back in the early 1900s, psychology and education were dominated by two heavy hitters: structuralism and behaviorism. Structuralism was obsessed with breaking everything down. The idea was that if you could just analyze every single sensation and feeling in isolation, you could figure out the human mind. It was like trying to understand a car by taking apart every screw and bolt, but never actually driving it. Then you had behaviorism, which really took hold in the American education system. Think of Ivan Pavlov and his dogs, or B.F. Skinner and his pigeons. Behaviorism viewed learning as a simple transaction, stimulus and response. If a student does a math problem right, give them a gold star, positive reinforcement. If they mess up, correct them. It assumed that if you just drilled specific behaviors enough times, learning would happen. It was very mechanical. It treated the student like a machine that just needed to be programmed. Enter the Gestaltists. The movement was kickstarted by Max Wertheimer, along with his colleagues Wolfgang Kohler and Kurt Koffka. They looked at what the structuralists and behaviorists were doing and basically said, "You guys are missing the forest for the trees." Wertheimer had this epiphany while looking at flashing lights at a train station. He noticed that if two lights flashed at just the right speed, it didn't look like two separate lights turning on and off. It looked like one light moving back and forth. This is called the phi phenomenon. Why does this matter for education? Because it proved that our experience of the world isn't just a compilation of sensory inputs. Our brains add something to the mix. We organize reality. We create structure. The Gestalt psychologists argued that learning isn't just about piling up facts like bricks in a wall. It is about how those bricks fit together to make a house. They believed that the human mind naturally seeks patterns and wholeness. When we apply this to education, it flips the script. We stop treating students like empty vessels waiting to be filled with data points and start treating them as active thinkers who are constantly trying to make sense of their environment. The core maxim, the whole versus the sum. Let's circle back to that famous quote. The whole is different from the sum of its parts. In a classroom setting, this is huge. Let's say you are teaching a history lesson on the American Revolution. If you take a purely atomistic approach, breaking things down into atoms, you might have students memorize a list of dates, 1775, 1776, 1781. Then you have them memorize a list of names: Washington, Jefferson, Cornwallis. Then maybe a list of battles. A student might ace the quiz on those dates and names. But do they understand the American Revolution? Probably not. They have the parts, but they don't have the whole. They don't see the tension between the colonies and the crown. They don't feel the desperation of Valley Forge. They don't grasp the philosophical shift toward democracy. Gestalt theory says that the whole, the concept of the revolution and its impact on the world, has a meaning that you simply cannot find in the isolated parts. The dates and names. The meaning emerges from the relationship between the parts. As educators, this means our job isn't just to dish out content. It is to help students construct the whole. We need to present the big picture first, or at least provide a framework where the details make sense. If we don't, we are just asking students to memorize nonsense. And let's be real, rote memorization is the fastest way to kill a love for learning. This brings up the distinction between sensory reality and phenomenal reality. Sensory reality is the raw data, the sound waves hitting your ear or the light hitting your retina. Phenomenal reality is what your brain actually perceives, the song or the painting. In the classroom, the teacher provides the sensory reality, the lecture, the textbook, the slideshow. But the student constructs the phenomenal reality, the understanding. If we want that understanding to be accurate, we have to present information in a way that aligns with how the brain naturally organizes things. A laws of organization, a teacher's toolkit. The Gestalt psychologists didn't just talk in metaphors. They identified specific laws of organization, sometimes called the laws of grouping, that explain how our brains sort information. These aren't just for graphic designers. They are gold for teachers. If you can tap into these laws, you can design lessons that stick. Let's break down the big ones and see how they play out in a school setting. 1. The law of proximity. This law states that things that are close together are perceived as belonging together. It sounds simple, right? But think about how often we mess this up. In the classroom, imagine a whiteboard. If a teacher writes a vocabulary word on the far left and the definition on the far right, with a bunch of random announcements in the middle, the students' brains have to work overtime to connect the two. That is unnecessary cognitive load. To use proximity effectively, you group related concepts physically close to each other. If you are teaching the water cycle, you draw the evaporation arrow right next to the water, and the condensation cloud right next to the vapor. You don't put the label precipitation in the corner of the board just because you ran out of space. You organize the physical space of the classroom and the visual space of your handouts so that related items are buddies. 2. The law of similarity. We tend to group things that look alike. This applies to shape, color, size, or texture. In the classroom, color coding is the best friend of the law of similarity. Let's say you are teaching English grammar. You could put all the nouns in blue, all the verbs in red, and all the adjectives in green. When a student looks at a sentence, their brain instantly groups the blue words as having a similar function. It creates a visual pattern that supports the grammatical rule. This also works for math. If you are solving a complex algebra problem on the board, use one color for the variables and another for the constants. It helps the students see the teams of numbers and how they interact. It's a subtle tweak, but it helps the brain categorize information without even trying. 3. The law of closure. This is one of my favorites. The law of closure states that our brains are uncomfortable with gaps. If we see a circle with a small piece missing, our brain automatically fills in the line to see a complete circle. We want resolution. We want wholeness. In the classroom, this is the secret sauce of active learning. If you spoon-feed students every single answer, you are denying them the chance to use closure. They become passive. Instead, you want to leave meaningful gaps. Ask a question and let the silence hang there for a minute. That tension, that's the brain itching for closure. When a student finally raises their hand and provides the answer, the closing of that mental loop creates a stronger memory than if you had just told them the answer. You can also use this in lesson structure. Start a class with a mystery or a hanging question. Why did this civilization collapse overnight? Spend the lesson exploring clues. The students will be engaged because they want to close the gap you opened at the start of the hour. 4. The law of continuity, or good continuation. Our brains prefer to follow smooth, continuous paths rather than abrupt changes. We like flow. In the classroom, this is all about curriculum design and lesson flow. A lesson shouldn't feel like a series of jagged, disconnected activities. It should feel like a stream. The warm-up should lead naturally into the lecture, which flows into the practice, which flows into the assessment. If you're switching topics abruptly, okay, put away your math books. Now let's talk about the Civil War. It takes a lot of mental energy for students to switch gears. Good educators build bridges. Just like we balanced that equation, let's look at how the North and South were trying to balance power in the Senate. Okay, maybe that's a stretch, but you get the idea. You want to create a narrative thread that runs through the day. 5. The law of figure ground. This is the face-vase concept again. We organize our visual field into the figure, the thing we are focusing on, and the ground, the background. We can't focus on both at once. In the classroom, this is crucial for classroom management and attention. In a classroom, the figure should be the learning material. Everything else is ground. If a teacher is lecturing while standing in front of a busy, chaotic bulletin board, the students' brains are fighting to decide what is figure and what is ground. If you are showing a video, but you are talking over it, you are creating a conflict. The auditory figure, your voice, is clashing with the visual figure, the screen. To use this well, you need to eliminate distractions. When you want students to focus on you, make yourself the clear figure. Stand center stage. Silence the room. When you want them to focus on a text, step back. Fade into the ground. Don't be the sage on the stage when you need to be the guide on the side. 6. The law of pragnans, simplicity. This is the overarching law. It says that reality is organized or reduced to the simplest form possible. Our brains hate chaos. We want simple, clear, symmetrical forms. In the classroom, keep it simple, stupid, kiss. I don't mean dumb down the content. I mean simplify the delivery. If your PowerPoint slide has 5 different fonts, 3 contrasting colors, and a spinning animation, you are violating the law of pragnans. You are creating visual chaos. Present complex ideas in the simplest format possible first. Once the students have the basic structure, the simple form, you can add the nuance and complexity. But if you start with the chaos, you will lose them.